So, good evening. Do you know that degenerative diseases of the brain, like Alzheimer's, Parkinson's, amyotrophic lateral sclerosis, Huntington's disease, multiple sclerosis, and others, affect over 45 million people worldwide? It is also known that as we age, we all become more at risk for degenerative diseases of the brain. The statistics are that by year 2050, over half of all baby boomers will have Alzheimer's or some other dementia. I ask myself, is it just a natural consequence of aging? Or is there something else going on here? I'm a person who lives with a chronic neurodegenerative disease called multiple sclerosis. I was diagnosed with this disease in 1970 at the age of 20. After having had 2 episodes of optic neuritis, which is inflammation of the optic nerve with fogging over of the vision, I was prompted to consult a neurologist. The neurologist, upon his physical findings, which indicated other neurologic signs and a spinal tap, confirmed the diagnosis of multiple sclerosis. At that time, the doctor told me there was no understanding of what caused the disease. There was no cure. He could not predict how quickly the disease would progress, nor how disabled I might become. You can imagine that this is pretty disturbing and life-changing information for a 20-year-old. One curious symptom, actually what I want to go back and tell you is, though, I am fortunate. Unlike many others who get diagnosed with this disease and become very disabled, I am still able to walk with the aid of a cane. I am able to work. I swim for exercise. I am fortunate. I have had one curious symptom starting early in the onset of this disease called myoclonic contractions. These are involuntary muscle jerking motions that can involve one muscle or groups of muscles. For me, they happen in my legs. Episodes can have a duration of anywhere from 15 minutes to 2 to 3 hours. And oftentimes, these will occur in the middle of the night and persist for 2 to 3 hours and keep me awake. They're not painful, but they do keep me awake. I've also noticed an interesting connection between these episodes and my consumption of sugary foods. In fact, the symptoms of myoclonic contractions, which I have dubbed my mini leg seizures, occur so reliably and so consistently after eating concentrated sugars that I have wondered whether I should worry about this signal symptom and its association with sugar. I'd like to talk a little more about the food connection. Our ancient ancestors, dating back to about 2.5 million years ago, up until about 10,000 years ago, did not eat 3 meals a day plus snacks. They were nomadic hunter-gatherers, and they subsisted on a diet of wild berries, tubers, leafy greens, nuts, wild game and fish, insects, some wild grain. All of these foods are in the very low carbohydrate category with a very low glycemic index. The glycemic index is a measure of how quickly the food will raise the blood sugar. I wonder to myself, how is it that our ancient ancestors managed to survive and even thrive over the millennium in very hostile environment and climate change on such low carbohydrate foods, and even during periods of famine? The only answer can be is that their bodies were not depending on the glucose derived from carbohydrates. Their bodies had adapted to a different energy system called ketogenesis. Ketogenesis is the breakdown of fat into ketones for energy. And ketones are every bit as supportive of muscle tissue and brain as glucose. Well, let's fast forward to current time, when the availability and the quality of our food has changed dramatically. Much of our food is now derived from highly refined and highly processed carbohydrate. The consequence of a diet that emphasizes carbohydrate and refined carbohydrate is elevated blood sugar. Chronically elevated blood sugar can result in insulin resistance. Insulin resistance is a diminished ability of cells to respond to the presence of insulin transporting glucose into muscle and other tissues. Paralleling this modern dietary phenomenon is an increased incidence of diseases like diabetes, cancer, autoimmune diseases, autism, seizure disorders, and neurodegenerative diseases like multiple sclerosis. There is now strong scientific evidence that correlates chronic hyperglycemia and insulin resistance to neuronal damage to neurons in the brain. I ask myself, well, what is this about elevated blood sugar and insulin resistance and damage to neurons? Well, neurons are basically glucose gluttons. Our brains use over 60% of all the glucose generated from the food that we digest. So the problem for neurons is that so what is this connection? I'm losing my train of thought here. Hyperglycemia and insulin resistance deprives neurons of energy and oxygen. And when they're deprived of energy and oxygen, they become very stressed and they die. So the consequence of insulin resistance, energy and oxygen deprivation, as I said, results in neuron death. It is now interesting that the scientific community has identified Alzheimer's as type 3 diabetes, or insulin resistance of the brain. Another piece of this puzzle has to do with glutamic acid. Glutamic acid is the most abundant amino acid in our food. And for the most part, it is locked up in a very tight protein called a peptide chain. When we consume it, it's broken down in our digestive process and enters our bloodstream slowly. Glutamic acid is also made in our brains, where it is found as glutamate. And it is a potent neurostimulant and very important neurotransmitter. It's an important neurotransmitter responsible for cognitive function, learning, and memory retrieval. Now for neurons, each neuron makes glutamate, but it can only handle it in very small amounts. It's such a potent stimulant. An overabundant exposure to glutamate can cause neurons to fire rapidly and repeatedly and die. When neurons die due to energy and oxygen deprivation, they dump their stored glutamate into the brain. Glutamate then becomes what's called an excitotoxin, where it will damage and kill neighboring neurons. Hyperglycemia triggered glutamate excitotoxicity, that's kind of a big one there, is involved in many neurodegenerative diseases now. It's recognized as being involved in very many neurodegenerative diseases. Further evidence of the potential of the damaging effects of glutamate is found in when there are concussive brain injuries, trauma to the brain, or stroke, where large areas of the brain are damaged and many neurons are dying simultaneously and releasing their stored glutamate into the extracellular spaces of the brain. And then we have what is called a glutamate storm. There is so much glutamate accumulating in the brain around healthy neurons, those neurons then also get overexcited and die. There are now drugs out there called glutamate blockers to try to intercede on this damaging phenomenon post-stroke and post-traumatic brain injury. I'd like to tell you two stories. One is that I have a friend who had a baby girl who was born ancephalic, missing part of her brain. That baby had frequent traumatic grand mal seizures. The drug therapies were minimally helpful. The mother had heard about the ketogenic diet for seizures, researched it, and started feeding her child this diet. This diet is 90% fat and 10% protein. Those seizures stopped. The doctors had told her that the baby probably wouldn't live beyond 2 years and would never see and never hear. That child is now 20 years old. Although she is profoundly disabled, she does see and hear, and her seizures are still controlled by the ketogenic diet. The other story is about a doctor, I found it online actually, Dr. Catherine Reed, who is a biochemist. Her daughter, who is 3 years old, was diagnosed with autism. Again, this was a situation where the drug therapy was minimally helpful. This was a moderately autistic child. Even so, the child was very insular, had no eye contact, was not social, had frequent tantrums. Catherine Reed researched and heard about dietary approaches for treating autism, and researched and refined the diet to exclude all foods that were, as much as possible, foods that were high in free glutamic acid. That child is now a normal functioning child, no longer considered autistic. I'd like to tell you a hypothesis that I have for myself, which is it possible that glutamate excitotoxicity could correlate to my mini leg seizures? And if I could control this dietary glutamic acid through the ketogenic diet, would it reduce or stop this symptom? Well, I started the ketogenic diet in October of 2016. This diet consists of 70% fat, 20% protein, and 10% carbohydrate. This diet excludes all grain, all simple sugars, and no fruit, except for some berries. The thing is, the body will not make ketones. if there is too much glucose present. As I mentioned, the classic ketogenic diet is 90% fat and 10% protein and very little, if any, carbohydrate. So I would like to go back to my story, which is I had a hypothesis about my own symptoms and the ketogenic diet. Shortly after starting the ketogenic diet, those mini leg seizures, which are myoclonic contractions, reduced dramatically. In fact, I can get through a whole night with no myoclonic contractions now, as long as I adhere to the ketogenic diet. It makes me wonder if my brain has something in common with these other disorders, seizure disorders, autism. It's very curious to me. In conclusion, I would like to say that although my talk is focused on the ketogenic diet benefits for neurodegenerative disease, the ketogenic diet has application and benefits for many other problems. Many of you probably remember the Dr. Robert Atkins diet, in which in the 1970s many people lost weight. The ketogenic diet can very effectively help people lose weight. There is a Dr. Adamo D'Agostino. He's a neuroscientist and physiologist doing research on the ketogenic diet and its ability to enhance cognitive performance and reduce the damage from concussive injuries in the military arena. He's also doing research on the use of the ketogenic diet to prevent and treat cancer. Cancers depend on glucose for energy to grow. And the ketogenic diet deprives them of glucose while ketones support normal tissue. Cancers cannot use ketones for energy. The ketogenic diet is useful to lower cholesterol, blood triglycerides, and lower abdominal obesity and prevent heart disease. So while it would seem that the ketogenic trend is turning the conventional medical advice to eat a low-fat diet on its head, it looks like sugar is actually the villain and not fat. And fat is more, in its natural, unaltered state, is more important to our health than we ever realized. Thank you.